Hello, fifth graders. So today we're going to be starting a brand new topic. So we've talked about adding fractions, we've talked about subtracting fractions, we talked about adding and subtracting mixed numbers. Now we're going to be multiplying fractions. So today's lesson is kind of all about how to model multiplying a whole number by a fraction. Now I do have to say, this topic is much easier, obviously, if you are in class with me because you can have a paper and pencil and we can kind of model these out. So I tried my best to make this as virtual friendly as possible. So just bear with me if we kind of run into some issues when we're modeling these. But for the most part, I made it so that you are still able to model multiplying a whole number by a fraction. Okay, and this is really important. The way we say it, multiply a whole number by a fraction, is different than modeling a fraction by a whole number, okay? So just keep in mind that today we have the whole number first and then we're multiplying it by a fraction. So let's look at this first problem. It says for the next 3 days, Mikey runs 2/3 of a mile each day. How many miles does he run over the course of 3 days? So 3 days, that's how long he's running. So that's our whole number. 3 whole days he's running, and each of those days he runs 2/3 of a mile. So every day for 3 days he runs 2/3. Okay, so that's our multiplication problem. 3 times 2/3, because we want to figure out how many miles he runs in total. So the first way we can model multiplying a whole number by a fraction is to draw it out. So you're going to model 3 wholes, which are the 3 days, and split each whole into thirds. Now, I already did that for you, okay? So that's 1 whole, 2 wholes, and 3 wholes. So those are the 3 days, and then each day is split into thirds because he runs 2/3 of a mile each day. Then what you're going to do is shade in 2/3 of each whole and count how many thirds there are in total. So on the first day, which is this day, he runs 2/3. So we can shade in 2/3. And what you can do, because these are little tables, you can either put an X in it, okay, or you can use the highlight bar and you can actually highlight that part of the table, whatever you would like to do. So this model is the first day, okay, 2/3 on that first day, 2/3 on the second day, and then 2/3 on the third day. So in total, how many 6/6 did I shade in? 1, 2, 3, 4, 5, 6. I shaded in, not 6, I'm sorry. How many thirds did I shade in? I shaded 6 thirds. Okay, so 6 thirds, which is the same thing as saying 6 divided by 3 is 2. So in total, he ran 2 full miles, okay? So that's one way to do it, just to draw it out, all right? Another way you can do this same exact method, drawing it out, is not to separate the thirds, okay? Not to go like this is 2/3 here, 2/3 for another day, 2/3 for another day. What you could do is continue your thirds. So this is 2/3 for the one day. This is 2/3 for the second day, and this is 2/3 for the third day, and you still get the same exact answer, 2 wholes. So 2 full miles in the course of 3 days. All right, so drawing it out, just kind of modeling it using thirds because that's our denominator, okay? The next way is repeated addition, because think about it. The first day he runs 2/3, the second day he runs 2/3, the third day he runs 2/3. All we're really doing is adding 2/3 3 times. So we have 2/3 plus 2/3 plus 2/3. And if we add that together, because they all have common denominators, you get 6/3, which is 2, okay? So the same exact thing, we got the same answer, but this way was just showing it using models. This way was showing using it repeated addition. And then the last way is basically just setting it up like a multiplication problem. And this is really how we are going to multiply fractions in this topic using this method. And this is really, really important. This important step right here. It says when multiplying by a whole number, because we're doing 3 wholes times 2/3. When multiplying by a whole number, you need to turn the whole number into a fraction. So always put the whole number over a 1, okay? 5 wholes is equivalent to 5 over 1. 24 wholes is equivalent to 24 over 1. Any whole number is the same thing as just saying that whole number with a denominator of 1. All right, so our original problem, 3 days, 2/3 of a mile each day. That's our original problem. Now we need to write it with the whole number over a 1. So it's 3 over 1 times 2/3. And now that that whole number is over a 1, we can just multiply. And this is what we do, guys. We just multiply straight across when we do multiplication with fractions. So this is different than adding and subtracting fractions because you do not need common denominators when you multiply fractions. This is pretty cool, okay? You just multiply straight across. So 3 times 2 is 6. 1 times 3 is 3. And we run into the same exact thing. We have to simplify. 6 divided by 3. We get the same answer that we got the last 2 times, which is 2 whole miles. So let's do an example of that method. 5 times 4/5. We want to write out with our whole number over a 1. So 5 over 1 times 4/5. And then again, when we multiply fractions, all we need to do is just multiply the numerators, multiply the denominators. So 5 times 4 is 20. 1 times 5 is 5. Now again, this we call what type of fraction? This is an improper fraction. So we can't keep it like that. So remember, this line we learned last topic stands for division. 20 divided by 5. 5 goes into 20 4 times exactly. No remainder, so our answer is 4. All right. So this last part, we're just going to practice. This is the method that you're probably going to be most familiar with, but we also want to make sure that we can model it using the repeated addition method. So this method is the repeated addition method, okay? And we also want to know how to model using just models, okay? Using fraction blocks and models like that, okay? So this problem is 4 times 3/4. So that's basically like saying, okay, let's say I shovel 3/4 of my driveway every day for 4 days. I want to figure out how much do I shovel my driveway after 4 whole days, all right? So you're basically doing 3/4 4 times. So you add 3/4 once, 3/4 again, 3/4 again, and 3/4 again. And since, again, they have all the same denominator, okay, you can just add the numerator straight across. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So you get 12 over 4. Again, this stands for division. So 12 divided by 4, and again, this is a basic fact, is 3. All right, and this very last one, this one is, it's showing the modeling that we saw in this first part. All right, so we have 6 wholes times 4/8. So what I have here is 6 wholes. Okay, those 6 rectangles represent the 6 wholes, and each whole is split into 8ths because our denominator is 8. So there's 2 ways we can go about this. I can shade in 4/8 in each whole. And let's do that way first. So 4/8, I can shade in 4/8 in this hole. That's 1. That's 2. That's 3. That's 4. That's 5 holes. And then this is our last time we're adding 4/8. So now what I want to do is just count all the 8ths. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 eighths I just counted. And again, this stands for division. So 24 divided by 8 is 3. Okay, so that is one way that you can model doing it this way. The other way that I showed you earlier is the same exact thing, but you can just continue your eighths. So this is one of the 4/8, but instead of moving to the second one, you can just continue the other 4/8 here. That's 2. That's 3. That's 4. That's 5. And lastly, that's 6. Okay, so this is showing 6 groups of 4/8. Okay, and if we count how many total wholes we have, 1, 2, 3, that's our answer, 3 wholes. All right, so what you guys are going to do, you are going to practice modeling some of these problems on the Google slide that is in the Google Classroom, okay? So again, these 2 ways are important to know because it tells me that you actually understand what is happening. You understand that when we say 4 times 3/4, we're really just saying 4 or 3/4 4 whole times, okay? Same thing with this, we're saying 4/8 6 whole times, all right? And then this last way to model is multiplication, which you will see for the rest of this topic. Just every time you have a whole number, you need to make sure you put that whole number over a 1, all right? So complete that Google slide in your classroom. Reference these notes as well. If you're unsure about how to model something, look back at these notes. That's why we take them, so that you can always reference them if you need to review a concept. All right? Let me know if you have any questions, and have a wonderful day. Bye, guys.